Alright, I actually skipped 24, so I'm coming back to 24 and then we'll go on to 27. So on number 24, it says find the x-intercepts for the graph of the function. At each intercept, state whether the graph will cross or bounce at the intercept. So we know, first of all, that we can find the zeros for each of these I should say for the function. Let's go ahead and find the zeros first because that gives us our x-intercepts as well. So first of all, we have a 0 of 3, negative 4, and if we set 3x minus 4 equal to 0, we're going to get 3x equals 4, which means x is 4/3. So 4/3 is our third 0. Let's go ahead and write these as intercepts. So 3, 0, negative 4, 0, and 4/3, comma 0. And again, the factor, or I should say the exponent on the factor, indicates the multiplicity. We learn if it's odd, then the graph, it will cross at that x-intercept. And if the factor has got an even power, then the multiplicity is even, and it's going to bounce, the graph will bounce at that x-intercept. So for 3, 0, we're going to cross. At negative 4, 0, because of that 4, an even number, we're going to bounce. And for 3x minus 4, that's to the first power, which is odd. And so that's also going to cross there. Alright, so let's move on to 27. Alright, so now we're going in the opposite direction of what we did in 26. So we need to write these each in exponential form. Remember on letter A here, natural log, that's base e. So we've got our 3 parts. This is going to be e to the x power equals 3. So in class, we did something like this. We started here and we went over here and into here. So e to the x power is 3. So base, exponent, answer, those are our 3 parts. So on part B, again, this is one of our special cases. If it's not written, we know that the base is understood to be 10. So let's go ahead and put that in. So here, if you start at 10 and you go around the world here, you're going to have 10 to the 3rd power is equal to 1,000, which is certainly true. That's one way to check yourself. Alright, let's look at C. So on 3, we're going to start with the base of 3 to the x plus 1 power, and that's going to be 15. So 3 to the x plus 1 power equals 15. Alright, let's look at 28. Now first of all, if we're going to graph this, this is a logarithmic function, but it's got a shift. In fact, because of that plus 3, we're going to have a horizontal shift. So we'll talk about that in a minute. First of all, we need to look at our parent function, which is just going to be the log base 4 of x. Now, trying to pick points when a function's in this form can be a little challenging. So it's a little bit easier to change this to exponential form. So our base is 4, our exponent is y, so we're going to have 4 to the y equals x. And now let's go ahead and make a chart. Now with exponential functions, something like y equals 4 to the x, we would have picked x to be negative 1, 0, and 1. With logarithmic functions, we actually pick y to be those values. It makes things easier. Notice 4 to the y power, or the 1 power, that means x would be 4. And if you put a 0 in for y, that'd be 4 to the 0 power, which would be 1, x would be 1. And we also know that this number here that goes with negative 1 will be the reciprocal of what went with 1, so it'd be 1/4. So let's go ahead and plot these points. We know we're going to have an asymptote at x equals 0. And let's draw this graph. And this is our parent function, y equals log base 4 of x. Now notice log base 4 of x plus 3, we said because that 3 is inside with the x, we're going to have a horizontal shift. If the plus 3 had been outside of where the x is, we would have had a vertical shift. So here, horizontal, we're going to go left 3 here. So this graph that we just drew, we need to move it left 3. Notice when the graph moves left 3, the asymptote will need to move left 3. So let's take care of that first. And let's move each of our 3 points left 3 and draw the graph. And so this is the graph of the function g that we were supposed to graph. Alright, let's move on to 29. Okay, so here it says use the properties of logs to expand the given expression as much as possible. So we talked about how to expand and how to condense these types of expressions. So we need our 3 properties. I'm going to go ahead and write them off to the right here. So we have the log of a product. This is called the product rule. That's equal to a sum of logs, 2 logs added. We have the quotient rule, where we have the log of a quotient, and that's going to be a difference of logs, or it equals a difference of logs. And then we have the log of a power, and that's where we move the power in front. So those are the properties that we have here. Let's go ahead and do this now. So notice what we have here. This is the log base 2 of 4 times x squared times the square root of y. This is a product of 3 things, the 4, the x squared, and square root of y. So let's break this down using the product rule. We can write this as a sum of logs, a log base 2 of 4 plus the log base 2 of x squared plus the log base 2 of, we could put the square root of y, but we don't have any properties that deal with square roots or radicals. So let's write that as y to the 1/2 power. That's another way to write the square root of y. And now we'll be able to use our power rule, which was the third one we did. So let's go ahead and break this down. We've got log base 2 of 4, but 4 is a power of 2. So remember, log base 2 of 4, that's the exponent you put on a 2 to get 4, and that would be 2. On the second log here, we can use the power rule and move that 2 in front, because we want to be taking the log of a single value. In this case, it's x. And we can do the same thing with the last one. We can move that 1/2 to the front. And that's as much as we can, as far as we can go to expand this. So now on 30, we're going the opposite direction. So first of all, notice we have a subtraction of 2 logs, and both of them have a 1 in front, so we can use the product rule, the quotient rule here, and write this as the log of a quotient, a over b. Now don't forget, let's rewrite the other log, but since we have that 3 out front, we can't use the product rule or the quotient rule if that 3's out in front, so we're going to move that using the power rule. So this will be log base 2 of c cubed. So now we have a sum of logs. We can use the product rule because they both have a 1 in the front. And so it's the log of the product of a over b times c cubed. Let's go ahead and write c cubed over 1. When we multiply, we get the log base 2 of a c cubed over b. Now I want to show you something here. We talked about this in class. Notice here we're positive, and so the a ended up in the numerator in our final answer. For this log, we're negative here, so that b ended up in the denominator. For this last log, we were positive, and so that c cubed ended up in the numerator. So that's something to look for when you're either condensing or expanding logs. Alright, let's look at number 31. So in this problem, we're using the formula here to the right. So let me write that out. And let's see, let's identify our parts. P would be the initial amount invested, and our interest rate, let's write that as 0.06. Since it's compounded monthly, that means 12 times a year they're applying interest to our account each month. So N is 12. So how much money would you have after 13 years? That means T is 13. That's everything we need to know. Let's go ahead and plug those in. So once you plug those in, it's just a matter of putting that into your calculator. Do not forget to use the caret symbol right about there. And you would want to put this in parentheses when you do that, or just make sure that we're taking it to 12 times 13 to that power. Alright, let me just get those out of there. And when you do that, you should get $4,354.47. Now notice it asks how much interest we earned. So basically what we have here is the amount in the account after 13 years. We started out with $2,000. So if we subtract $2,000 from this, we get what we actually earned in interest. So that's going to be $2,354.47. Alright, let's move on. Alright, I think I'm going to go ahead and stop here and then we'll start again. Actually, no. Yeah, we'll stop here.